and PhD in the field of building material research at Bauhaus Universitas Weimar, German. He holds an MBA from ETH Zurich, Switzerland. He works research in the concrete industry before started in Sika and Zurich in 2009. He has functioned as market developer manager. He provides global technical support and business development in the field of gypsum and dry mortar additive and concrete admixture. Okay, let's give our full attention to Dr. Markus Mueller and join me and welcome you, please.
Thank you very much. First of all, short question. Can you see full screen my presentation?
Okay.
You can? Super.
You can.
Then again, my warm greetings from Switzerland. And congratulations to HAKI. And hello, everyone. You can hear me well?
Yeah, very well.
Very good.
Yeah.
So I'm glad I get the opportunity to introduce our company and our solutions for concrete to you today. And I want to thank the organizer for giving us this opportunity. So for those of you who don't know the company Sika yet, Sika is a specialty chemicals company. We produce products for many different applications, from bonding, sealing, damping, reinforcing to the protection of buildings. But also we provide solutions to other industries like the motor vehicle industry. Worldwide, around 25,000 people work for Sika, and we have more than 300 plants distributed all over the world in 100 countries. And very often our little molecules and our products are somewhere hidden inside many different products like concrete. And you don't see, of course, that there is Sika inside. When I'm talking about the different application fields, to give you a total overview, besides concrete, we provide solutions for waterproofing, for roofing, for building finishing, flooring and coating, sealing and bonding, refurbishment, and as said, for other industry applications. Of course, in today's world, where we are facing a fast change in technology, a fast movement, a fast development, we need to have a strong power in research and development. And more than 1,000 people work in the research and development department at Sika, distributed in 21 technology centers all over the world. And when I'm introducing now to you sustainable solutions, I want to point out that sustainability, or the complete sustainable solution, does not only mean that there is a benefit for the environment or for the climate or anything else in this regard. No, actually, it means the combination of a performance solution with a sustainability solution. So the target is adding value to our customers, but without compromising on environmental and sustainability aspects. But what does it mean in detail? Let's look at precast concrete in particular. Many of you are very familiar with the precast element value chain. It starts with the design phase over the certain production steps to the service life, of course, where most of you are interested in that the products are, so the elements are sustainable, that they are long-lasting, and that they are fulfilling the requirements of the applicators. But to the final process where they have to be demolished and can be partially transferred back into the process of new elements, the so-called recycling process. And for each of these steps, we at Sika would like to provide solutions. It starts in the design phase, where we provide handbooks and software and apps and also calculators. Special tools, you can download them on our homepage, but of course, even more important to talk to our experts who can guide you in the selection of the right tools. Then it goes through the different production steps where products like Sika Separol, mold release agents, and joint sealings, so-called Sika Flex products, can be used for the preparation of the molds. There are products like Sika Fiber, micro and macro fibers, which can substitute partially or even completely reinforcement. So heavy steel mesh that takes a long time in the production process of concrete elements can be substituted by fibers, and that saves a lot of time and money for the whole process. Then during the mixing phase, we have developed a very important range of products under the so-called Sika Viscocrete brand name, but I will talk more in detail about this in a later slide. Also Sika Stabilizers, a product group which helps dealing with impurities in concrete that may come from aggregates or simply because certain raw materials are fluctuating in their quality. Then during the casting and finishing phase, we have dedicated products like Sika Retarder, just to mention them, who actually can enlarge the setting time even further. So if it's required to process a concrete not only for 30 or 45 minutes, but 1 hour, 2 hours, or even 5 or 6 hours, that's all possible with chemicals. And that's done by so-called Sika Retarder technology. At the same time, products like Sika Rapid can accelerate the hardening process. This is especially relevant in the production of elements where a high speed of production, a high capacity utilization is necessary. Let's talk, for example, about, as seen on the pictures, about tunnel segment production. There, it is possible by the use of such accelerators to reduce the total heat during the curing phase, to save with that not only time but also energy, and of course also improve the durability. There are further products like Sika Antisol and Rugasol for curing and surface retardation, and further products, and I don't want to mention each of them, just the big group of products under the service life field, where admixtures can improve the aspect of concrete. So talking about colors, depending on the needs of a of a customer or an architect, it is possible to produce green or red or yellow or blue concrete or black concrete. And of course, especially for those who are interested in the aspect and the look of these elements, it's important to have a dense and homogeneous surface. For that, products like Sika Fume, that's silica fume-based products, and at the same time, Sika Control surface improver can have a very positive effect and can also enhance the aspect of such concrete elements. Last but not least, we have developed a unique recycling process, so-called recover process, which allows to during the demolishing phase of concrete to create again very clean fractions of aggregates, which can be turned into new concrete mixes. And the good thing is that this process not only creates very high quality raw materials again, but it even consumes CO2, which is another positive benefit for the climate. And when I'm talking about climate, you know, not only the climate is changing, also our societies and the economy is frequently developing and changing. We have global megatrends. We see laws and regulations are changing. We have issues on our construction sites, and all this together brings challenges also for concrete, for the production of concrete. Just to mention some important ones, carbon neutrality, resource efficiency, and productivity increase are challenges for every concrete producer. And I want to show you on my next slides some approaches how Sika would like to provide new approaches and new solutions to the industry to allow fulfilling such needs and dealing with such challenges. And if we look now at carbon neutrality, for example, we provide to cement producers special additives, so-called Sika grind additives, which allow producing cement more efficiently. Such polymer solutions that are used here, first of all, improve the milling process, so the production process of cement, but also they improve the quality of the final cement. So such additives allow the usage, for example, of supplementary cementitious materials like slag, like fly ash, which can reduce the clinker content in the cement significantly, and with that improve the durability of concrete, but also the environmental footprint of concrete. There are even more dramatical changes possible, like the so-called LC3 technology. LC3 means limestone calcined clay cements, but I go in more detail on my next few slides, because this is technology where we believe that it will have a big impact in the future, and so I would like to share some more insights on this topic with you. An important role for many different applications plays the PCE technology. PCEs, polycarboxylate ethers, are molecules. They are dispersed in water, and those molecules can adsorb on specific surfaces, like on cement and other ingredient surfaces, and hinder that other solid particles contact each other and improve at the end the flow properties, reduce the water demand. So PCE technology is a very important tool in the fulfillment of different different aspects in the concrete production. As mentioned, also the recover process, which plays an important role in the use of secondary raw materials, recycling raw materials in the concrete production process. To give you a rough estimation which impact these little ingredients can have, you know, we are talking about very little amounts that are added to concrete. For example, for a superplasticizer, this could be 5 kilograms per cubic meter. And such small amounts can have a huge impact, as you see here. The grinding aids, for example, the picture on the left side, can have an effect of about 20% CO2 reduction during the cement production. And if we even add the effect of superplasticizers and concrete admixtures on the concrete production process, then this sums up to a total of about 40% effect of grinding aids plus concrete admixtures on the CO2 reduction of concrete. So little drops of some magic liquids, and the effect can be really, really huge. But not only on the CO2 reduction, also on the efficiency regarding the use of raw materials. We have developed a technology or a concept, the so-called Sika code concept, which allows the use of different sands, even sands that have been that have not been successfully used for the concrete production. So sands with impurities inside, sands where the sieve curve is not meeting the concrete requirements. So for such solutions, we provide here support, the code concept, and I will show you a bit more on a later slide. A couple of solutions for durability enhancement, for water reduction, and today even some of these technologies can be made from bio-based raw materials. We are proud to be the first company in the world who is producing industrially the bio-based Sika viscocrete, so polycarboxylate ethers. And this is working well, not to 100%. Such bio-based raw materials can substitute the crude oil raw materials, but it is possible, and we are pushing this technology to get used even more. Last but not least, on the productivity, our concepts are helping, like the concrete admixtures. I've told about them, but also digital tools, the Sika Fiber software, the Sika Mix Design app, the Sand app, tank level management, and others. And you know, the industries are significantly using new digital tools, new automation tools, and our concrete production of today is turning more and more into an industry, and a big, I would say, one of the highest developments is the modular building, where the complete elements with the installations of electrical, of water supply, etc., can be made under secured environment in a plant and then transported to the job site. And our intention is to provide for such production complete solutions. So Sika as a one-stop shop for such production. You may have heard or seen 3D concrete printing, an interesting development that has significantly fast developed during the last years. Even the first buildings, houses, even some bridges have been built now. So there is high speed in this development. Some of these 3D concrete printed elements are mainly used for architectural or for design purposes, but they are getting more and more also into structural applications. And we will see how this continues. We are on the forefront of the development of such technology. We have the complete system developed, and one solution is, for example, the Sikacrete 3D microconcrete that we provide here to producers of 3D concrete, printers of 3D concrete. A bit more details about the viscocrete superplasticizers. You see here a concrete mix which has nicely flown through this section of through this test, and actually this should simulate a concrete element where you have a high installation amount of rebars, of reinforcement, and the target is that this reinforcement is not hindering the flow of concrete, that the concrete can flow into every part of the mold without leaving any empty spaces or pores. And that's what the PCE technology can provide. And the unique thing of this PCE technology compared to other technologies like naphthalene or melamine based products, that those polymers, those PCE polymers, can be really tailor-made. So for different cements, for different concretes, for different applications, such polymers can be created, and they can even be combined. So there is, I would say, unlimited amount of architectural freedom in the use of such PCE molecules, with the result of saving costs, optimizing the performance in mixed designs, saving energy and water during the production of concrete, enabling such a nice flowing concrete, so-called easy or self-compacting concrete. With that, produce increasing the productivity, operational costs, quality, durability, and even enabling for our architects to create very slim concrete elements like high performance concrete or ultra high performance concrete. Talking about LC3, as said, you see here in the yellow box, there is a combination of 50% clinker in such a cement, plus 30% calcined clay, plus 15% limestone, plus 5% gypsum. So that's a pretty common LC3 formulation. And you see the clinker has been reduced by 50%. That's a unique or a very high amount. And such a formulation can result in similar strength like a pure 100% SEM 142.5. And there were issues at the beginning with such cements. You see here on the chart that the yellow curve or yellow line has a much lower flow table spread. This is the pure LC3 concrete without the use of Sika LC3 admixtures. And by adding our admixture solutions, we were able to not only meet the final concrete properties, but also meet the early strength development of such a concrete, to also meet the flow properties of such a concrete, similar to the one of a ordinary normal concrete. And that's, we believe, one of the key technologies. We know such raw materials, calcine clays, limestone, they are widely available. And we believe, and that's not only us, also scientists who work on the cement development believe that those cements will represent about 20 to 30% of all cements by 2050. So we believe in the future of this cement, and we have the admixtures ready to allow for the usage of them. I said already something about Sika Rapid, about the accelerators. The early strength improvement is here the key, which gives actually several benefits. And most important, as you see here on the chart, the yellow curve or the yellow line is actually the heating in a tunnel segment production, the heating during curing up to, what is the temperature range here, up to 90, 95 degrees after 6 hours. And you see with the blue curve, we were able to stop the heating at an earlier time, and most importantly, resulting in less concrete temperature. So the concrete temperature, which is here the dashed line, did not exceed 70 or 80 degrees as the yellow curve, but it was below 60 degrees. And this is very important for hindering that cracks are formed in concrete, micro cracks that can be very negatively impacting the durability of concrete. So this is a key here, and we are happy to provide a solution for the concrete industry to make more efficiently and also more durable concrete. Okay. Fibers are playing an important role, microfibers for hindering crack formation, but also macrofibers, which can partially or even fully replace steel bars and reinforcement. That saves time and money in the construction process and even improves safety, durability, and serviceability of concrete. And the good thing is those fibers can be easily handled, even automatically dosed nowadays. So this is all possible. And by the use of Sika fiber design software, you can even designer can already work with the fibers instead of the bulky steel bars. Finally, I told you already about the importance to replace, with other words, aggregates play an important role in the use of concrete, not only for the performance of concrete in the fresh state, but also in the hardened state. Because those aggregates, they make in the range of 75% of concrete and mortar formulation. And what we have developed is a concept, so-called code concept, where we analyze the concrete mix design and the raw materials and develop or provide different solutions. So we have developed special analyzation tools. You see an app, for example, for the adjustment of the sieve curve, of the particle size distribution of aggregates. You see also a special ring test here, where we have tested the effect of impurities like swelling clays on the concrete or mortar performance. And different technologies are hindering or are balancing out, better to say, the negative effect of bad performing aggregates. So last but not least, my last slide, we are living in a fast changing environment. Megatrends like sustainability and digitalization drive the growth in the construction industry. And I hope I could show you that we are ready to work together with you using our more than 100 years experience, bringing in our innovations, working together with you on your specific systems with our experts hand in hand, and providing you a wide range of solutions and products. With this, I thank you very much for your attention and look forward to better times when we can meet face to face again. And I wish all of you success, but first of all, stay healthy and take care, and look for your families and stay safe. Thank you.
Thank you, Dr. Markus Mueller. This your presentation. We have two question from the participation. One question: how do you recycle concrete? It's cost efficient. Do you the quality degree or not?
Regarding recycling, correct?
You lead a question and answer.
Yeah.
How do you recycle concrete?
Yeah. It's about the recycling process, the so-called recover process. It's a special treatment of demolished concrete. So first of all, when an old building gets separated into the different raw materials or ingredients, the concrete waste will have to be grinded, so it gets into smaller fractions, and then it turns into a special device where high CO2 environmental is around, and there we are accelerating or accumulating the carbonation process. So the cement stone gets quickly carbonated, and that leads to a significant destruction or strength reduction in the microstructure of the cement paste. So with some further mechanical work, such microstructure can be broken apart, and after a sieving process, the very clean aggregates can finally be turned back into one-to-one substitution of new non-recycled aggregates. And there is, of course, also some cement paste, which can be used for other purposes, but there is a really clean aggregate after this process. And I'm happy to provide you more information on this. We have a patent on this technology, and we are happy to introduce it to everyone. Please contact me. Let me know your contact details, and I'm happy to go deeper in that. Or contact Sika Indonesia, who is also, of course, available for you. There are further questions, right?
Okay, thanks. Number 2 question from Praditya Mulya Japri. Great information, Markus. I have question. Do you Sika have product to protect reinforced concrete rebar corrosion by chemical attacks, which it's for soil and water with high sulfate and chloride contents? Thank you.
Yes, yes. There's a technology available which is added to concrete to make it denser and corrosion protecting. This special technology is working in combination with other ingredients. So a key is always to make here a dense concrete using high range water reducer technology. So also viscocrete plays here again an important role. But I would again invite Mr. Japri to contact Sika Indonesia or directly myself to go deeper in his case. That it is never only one magic ingredient. It is always the combination of, or the adjustment of all the ingredients. So the mix design plays here an important role, and also the quality of the and the consistency of the raw materials. So I would invite him to continue optimizing his formulation on a direct call. And there is another question I see on the 3D concrete.
Okay, 3D concrete.
About the strength of 3D concrete. The strength of this mortar, I mean, it's we have to be honest here. It's a micro concrete. Those who have seen a video of such 3D concrete, we're not talking about 8 millimeter or 16 millimeter or even more aggregate size. We're talking about a micro cement, a micro concrete. And these formulations contain a lot of admixtures also, so they can be formulated to very high strengths, up to I don't have the figures in front of mine, but I'm estimating it is at least 40, 50, 60 megapascal, or even more is visible. We have here also different micro concrete formulations. So I would say the limits are very, very high. And yeah, but it is never a very easy or low performing concrete. Is always a relatively high performing solution. That's why such thin 3D printed objects can be created. Very thin, architecturally interesting. I hope I was answering all the questions, and thank you again.
Okay, thank you. Thanks, Dr. Markus. Thank you for the presentation of the HAKI. The next presentation of ini presentasi selanjutnya ya, apa namanya, ke perkuatan steel girder dengan external preset oleh Dr. Josia. Thanks, Markus. Okay.